Okay, good afternoon. So today's lesson is about power equations. So that's also a simple equation. And then I will follow exactly the Origo book, but I haven't received the old version yet. But hope you see that there is no difference at all between this part and the old version. So what is a power equation? So let me just motivate you a little bit, then we can come back to the book directly. So a power equation, so far we have studied equations and sometimes we also solved a little bit harder equations, but I don't know, have you noticed there is one thing in common in all equations that we have treated so far? They had something in common. Some equations were simple, some equations were harder. I don't know, sometimes we had fractions, sometimes we didn't have any fractions. But there are two characteristics in common for all of them. What are those two characteristics? Yes? No, equal sign is always yes. That is the definition of an equation. So that is not something we need to mention here, because if you don't have equality sign, you do not have any equations in the first place at all. Yes? But I'm talking about all the equations that we had. Of course, it is clear that all of them should have the equality sign, but there is something in common to all of them. Yes, Ibrahim? Unknown. Explain more. X, or like maybe that you're trying to find. No, that is the meaning of equation again. But the equations that we, yes?
They were unknown variables, like some power, or like numbers.
Yeah, so one thing is that there were no powers on top of the unknown. All the time, if you have go and visit the equations we have been treated so far, the x appears with just power 1 in that equation. So that is something different today. This is why it's called power equations. It means that you should expect to increase the power. Yes? And the other thing is that, of course, all equations we had so far contain one single variable or unknown. Later in Math 2C, we will also learn how to solve equations with more unknowns in them. That would be systems of equations. But for example, and by the way, this is a good example in the book. So just if you watch this here, this is a good motivation. Why we say that we need this. For example, assume that this is a square. If I give you the length, you can definitely calculate actually the area. But the question is the other way around. Sometimes you know the area for some reason, and you are interested in finding the length of that. So what does it mean? It means that if you want to solve that problem, you would say that, okay, I have this x here, and this is 25 meters squared. So this means that if I want to find this length of this square, I don't know it. Do you remember yesterday we talked about setting up equations? So I would say, what is this x so that the area becomes 25? But you already know how to calculate the area of a square. How do you do that? You say that, okay, I take this length and multiply it by that, which becomes x to power 2 is equal to 25. And then you are supposed to find x. This is I'm not saying this is hard, but this is different from the equations we had so far. Because you see that the unknown is x, but its exponent is bigger than, is not 1, is some number else, yes? So that is called a power equation. And then we are supposed to solve power equations. So what I want you to know exactly from the beginning, this is not possible to solve all power functions. Most of the time, most of the power equations, we cannot solve them. What do I mean by that? I mean, if, for example, this is a very simple equation, you can immediately guess the answers, okay? But, for example, if you add some terms to it, and if you ask me, can you solve this? I would say yes. This is a systematic, this is the second degree. It is already studied. Everyone knows how to solve that. But for example, if you increase this to power 3 and ask you the question, can I solve that x? I would probably say no. For the third degree, there are some tricks we can do. For the fourth degree, there are some tricks we can do. But Norwegian mathematician Abel actually showed that if the degree starts from 5 and going beyond, there is no guarantee. There is no formula that we can use that formula to find the possible solutions for that equation. This is just a general knowledge I want you to have. So I want you to know that solving equations of higher degrees, by the way, this is called a second degree equation. This is called a third degree equation. The highest power matters. This is not an easy problem. And of course, it is not a big obstacle because mathematicians actually have developed some techniques so that you can find the roots approximately, but to any desired accuracy that your problem demands. I don't know if you are solving an engineering problem, if you are designing some kind of car on Earth, the precision that you need is less than if you are designing a shuttle for space. If you for some reason reach to the same equation, then probably 1 decimal point is enough for you if you are doing something on Earth to design some car or something. But if you want to design a more advanced technology, even if you are facing to the same equation, you might need higher precisions. And then that's not an obstacle because mathematicians usually develop some algorithms that you, by repeating that algorithm over and over again, you can reach to any desired accuracy that you need for the problem that you are investigating. Okay, that's just a general knowledge. Okay, so that's what I'm saying. If you increase the degree, there is no guarantee that we can solve it. But you don't need to be worried because the ones that you are facing are very, very simple. And then later in Math 2C, we will also learn how to solve these kinds of equations that we have second degree in general. But that would be in Math 2C. Here, if I ask you, can you solve that? What is the answer? So it means that I am asking you to find all possible values so that when I square it, it becomes 25. So what are those answers or what is that answer? Yes, Turkey?
5.
Okay, 5. But is 5 the only answer? Because I told you that whenever I ask you to solve an equation, I mean to find all possible roots. Can you fix it yourself? There is also one more number so that it will work. Yes, Abdullah? Minus 5. So here it's 5 and minus 5. But of course, in this problem, because this is algebra, when you write this down, algebra doesn't see geometry. Yes, you know that this problem is supposed to solve this. This equation is supposed to answer this problem. So Turkel was right in some sense, because even though from algebra point of view we have two answers, but in this context, one of them is not acceptable. Yes, it is clear the negative one is not acceptable because it doesn't make sense if you say the length of the square is negative 5 centimeters, for example. Yes, it doesn't make sense. But if I ask you to do this in exam, so you have to set up this equation, you have to solve it properly and write it down that minus 5 is not acceptable for this problem. This is important because this means that you know the solutions are 2, but you understand one of them is not acceptable. But in other scenarios, might be I give you just this equation. For example, I would say that x to power 3 is 27. That is also a power equation because my unknown is x, but the power is 3. So what is that answer here? It's 3. Is this the only answer here? Yes or no?
No.
In this case? Minus 3 does not work. This is the case, this is the only solution in this case. Because if you say minus 3, it means minus 3 to power 3 is 27. But that is not correct. Yes? So this is not. So x equals to 3 is the only answer. So from now, so immediately you realize the difference between this case and that case. What do you think is important? What is the important difference between these two equations? Yes?
Exponent is even or odd.
Odd. So if you have an even exponent, always you get two answers which are negative of each other. But if you have an odd power, you get only one answer. There is also another difference where the oddness or evenness matters. What is that? Can you tell me? Yes?
3 square root. You do it.
No, I mean what? So for example, so I am comparing this equation to equal to something and this equation equal to something. The first difference we realized, for this one I get two answers, for this one I get one answer. But there is another difference. In this case, sometimes I do not get any answers at all. But in this case, I always get one answer. And that is the big difference. So if I ask you, what is the number so that it is raised to power 2 is equal to minus 16? What's the answer? There is no such a number. Yes, because I am raising a number to power 2. Even if you choose a negative number, when you raise it to power 2, it cannot be negative. But if I ask you x to the power of 3 is minus 8, what is the answer? It's still minus 2. So this means that, so this is important. This is the only thing that's important in our lesson today. Yes? So I have power equations of this type usually. Something is important to care about here, if the power is even or odd. If the power is even and I have a negative number on the right, you don't say the equation is wrong. You simply write the equation does not have any solutions. But if it is positive, then if you just write 4, that is not complete. You need to write 4 and minus 4. But for the case of the odd situation, it doesn't matter if I have a positive number on the right or I have a negative number on the right. I will have always and always one single solution. Of course, if you have a negative number on the right, your solution will also be negative. And if you have a positive number on the right, your solution will become positive. But in the case of even numbers, if you have positive answer here, you get two answers, positive and negative. If you get negative answer on the right, you don't get any solutions at all. So that is actually the summary of this lesson today. Is that clear? Yes? Okay. So let us, for example, so this is something I want you to know. Sometimes the numbers are not so good, so you have to use your calculator. Okay, so you have to use your calculator to answer that. So if I want to use my calculator, how do you do that? If I want to solve this equation, we can solve it in two different ways. Either we can say x is equal to a square root of 16, but I have to remember to put plus or minus. And then you continue. If this number is a friendly number, you can do it in your head. Otherwise, you can put it in the calculator. In this case, it is extremely simple. Square root of 16 is 4, and then I have plus or minus. And I want you to understand, you shouldn't read it as x is equal to plus 4 and minus 4. This is wrong, because it cannot happen that x is 4 and minus 4 simultaneously. This x plus minus 4 is a short way of writing x is equal to minus 4 or x is equal to 4. So whenever you see that I am writing something like this is the short way of writing this longer statement. Yes? Okay, another way to do that is to use the fraction power. So what you do, you raise to power 1/2 rather than that. And of course, some people are more comfortable with this because then they realize that 16 is what? 4 to power 2 and then to power 1/2. But we already know that these two exponents are supposed to be multiplied, but 2 times 1 over 2 is 1, so this becomes 4. But be careful again. If I just write this, then I will get one answer. So whenever you put this, you have to put plus or minus here as well, and this will continue until the very end, and then you get the same answer. Yes, is that clear? So these are the ones. And what happens if I do not have a friendly number on the right? For example, if I say x to the power of 2 is 5, and I ask you to solve this. So what are the answers? How many answers you have? Definitely 2, because this is even, and on the right hand side I have positive, so definitely I will have 2 answers. But this is not a number that I can know by heart. So I symbolically, what do I write? I would write x is equal to plus or minus what? Square root of 5, end of the story. But if I ask you to answer to 2 decimal points, to 3 decimal points, then I have to allow you to use the calculator, and then you put that number in the calculator and choose 2 decimal points, 3 decimal points, whatsoever. Yes? This is just the end of the problem here. Okay, if I give you this x to the power of 3 is equal to 9, then what's the answer? Yes? No. 3 is not the answer, because 3 to power 3 is 27, not 9. How do you read it? Yes?
I would. The first thing that comes to mind is plus minus cube.
No, not plus minus. Remember, it's not hard. Plus minus is for the case that you have even power. When you have odd power, there are no plus minus signs going on. Yes? Not square root. Cubic root. Or the third root. Whatever this number you see here, x is the third root of 9. Yes? If so this is the answer. For example, if I give you x to the power of 5 is equal to, I don't know, 40, then what's the answer? Yes, then x is the fifth root of 40. But do you know another name? I already talked about this. Can I write this in fraction power 4? This is important. I just remind you from our previous lessons. If you have nth root of a number, this can also be viewed as a fraction power, which is a to the power of 1 over n. So this is important. This is given in the formula sheet, but that is important to know.
40 to the power of 1 by 5.
Yes, you can also write 40 to the power of 1 over 5. So if I ask you to solve this, if you answer this, it is okay. If you answer this, this is okay. Usually this symbol in mathematics is called a surd. I would probably tell you write it in a surd form or write it in a power form. But if I don't specify that, that is up to you which one you want to choose. Okay, so is that clear? Okay. So I don't think there is something very interesting here. We already had this. Okay, so by the way, it's good to know. I don't know if they are using GeoGebra or not, but it is also good to see what is going on GeoGebra. Okay. I don't see any third root or whatever in GeoGebra. I don't know. Is there any way to do it? We can just Google it probably. But the point is, how do you calculate, for example, the third? For example, let me calculate these numbers. So you want to calculate the third root of 9 approximately. So what do you do? Because the buttons on the GeoGebra are just limited to this. We have the second root, but we do not have, for example, the third root. Some calculators I have seen, they also have third root on the bottom of the, what about the fourth root? What about the fifth root? So if you want to calculate this, you have to do it using powers. So this is important to actually understand here. This formula is important because otherwise you cannot calculate. For example, if I want to calculate the third root in GeoGebra, I think it would be better go to the CAS view, but this also probably will work. Let us test it, okay? I don't know, for some reason it is not working. Let me close it and okay, so here If I want to calculate the third root of 9, what should I type in? I just write 9, and then I would write to the power, and then I would write 1 over 9. 1 over 3, sorry. And this is the answer that you get in GeoGebra, 2.08. I have already adjusted GeoGebra to give me only 2 decimal points. You can increase the accuracy if you want to. But this is important. I can calculate 9 to power 1/3 to any degree of accuracy that I need. How GeoGebra knows how to calculate it? Because of the program someone has actually already programmed it. And that is coming from mathematics. So I want you to understand that even though 9 to power 1/3 is an irrational number and decimal points continues forever, mathematicians have already developed a method that you can get all decimal points if you need, one by one. There is no point to get all of them because there are infinitely many of them. But if in case you need 1,000 of them, you can push this algorithm further and further. It will generate you decimal points after decimal points. So that is also something I want you to know. And then let me just go to the next part, and I think there are some examples that we need to do. Okay. So here, let us, by the way, solve these 2 equations. So first of all, I want you to understand that these 2 equations exactly are today's lesson. So this first equation, what is the degree of this equation? The first one? This is second degree. What is the degree of the second one? It's also second degree. If I want to answer part B first, tell me, what's the answer? Not possible. Why? Because the power is even, but I have a negative number on the right. This is not possible. Yes? But if I ask you to solve the first one, what is your suggestion? And of course, I want to use GeoGebra as well, if possible, to answer up to. I think it is very easy. You don't need even to do GeoGebra here because the problem is extremely simple. Okay, but tell me what to do. So I want to write the equation here in front of you. 3x squared minus 5 is equal to 22. Okay. What I'm supposed to do? Yes?
You can first isolate the variable.
Yeah, because still the point is the same. I want to isolate x, make it alone. So I keep 3x squared here, and I move this 5 to the other side. The only thing that I have to be careful, I have to change the sign in this movement. And then I would write 3x squared. On the right hand side, I will have 27. Okay, what is next? Yes, be careful. I have seen some students take the square root immediately. This doesn't work because the square root will actually makes this even worse. Okay, so what should I do? I divide by 3. And then x to the power of 2 becomes 9. Okay, now you tell me, what is the answer?
3.
But some of you still say 3. Plus or minus the square root of 9. You can avoid this and just directly write plus or minus 3. So it means that if someone asks you how many numbers are there, you should say 2 of them, plus 3 or minus 3. Yes? Is that clear?
Yes.
Okay, so let us go now to see here. So for example, here this is something that we cannot solve unless we use some calculator or something. So here, this is the third degree equation. That is also the third degree equation. Let me ask you immediately, do you think number B has a solution or not? Why?
Because it's
Odd. This power, this is called degree, remember. The degree of this equation is 3 and 3 is odd. So how many solutions are there?
1.
1. It doesn't matter if this is positive or negative. And you also have the same answer, one single answer. What is the final answer? The answer will be positive from part A. From part B, the answer will be negative. Okay? And then if you want to use GeoGebra to calculate this, it doesn't, let me just do that and let us see how it goes. Oh, sorry. So I go to GeoGebra. So for that one, what should I write? For the first one, do you remember the number? I forgot the number.
12,000 something.
12,000. It was 12,167.
12, 1, 6, 7. So I trust you. So 12, 1, 6, 7.
Can you just check once?
Yeah, we can check. No worries. It is
I
not
think it was 0, 6, 7.
end of the story. Yes, to the power of 3. Yes, you are right. So that is the number that you get from GeoGebra. And the other one is probably, what was that?
That was minus 43.
Minus 43. So be careful. How should I type it now? If I want to do it minus 43, I would say minus, it should be in pairs of brackets. So it's minus 43 to the power of 1/3 again. Yes, and then you get minus 3.5. But 3.5 is an approximation. It's not the exact value.
Can you write like you did at the start without doing the
Yes, of course, this is the answer, but sometimes you have to write the exact answer. So if I ask you to find the exact answer, you have to write it and just leave it like this.
Then we're allowed to calculate, right?
Yes. Okay. So I don't think there are more lessons actually here today. Let us check. We have this lesson, so we know about that, and then you reach to exercises. But of course, the page number is a little bit different in this new version rather than the old version. So I will actually try to update the Google Classroom here. Because at 1:10, CMOS students are also coming to our lesson. They are supposed to sit in the back, and then you're also supposed to work here on your own. Yes, please? It is very similar to what we have. I have ordered this old version, but I don't know, because this is electronic version. Immediately they should give it us, but I don't have it. But this is very, very similar to what you have in the book. It's very similar. Okay. Any questions? So there are many actually questions. If you find it easy, I told you, you don't have to start from level 1. Yes, please come in. And then you can start from higher level ones. Okay? Okay, so I will update the Google Classroom and see all the students, and you also start working on what you are supposed to work. Okay? Any questions? No questions? Thank you.